Hello world, I'm Ryan, but you probably already knew that, because underneath the video, you can see that it was uploaded to my account, which has my name on it. Now you probably have a YouTube account yourself, and in fact, you probably have many accounts for many things. Just consider for a moment how many accounts you've registered since you started using the internet. Every app, email, game, store, social media, your banks, Netflix, this adds up to be a staggering amount. So you already know what accounts are and what they're used for. They're used to identify and confirm you are who you say you are, authentication, to control what you can view and do, authorization, and to keep track of what you do, accounting. When you go to log into YouTube, you are making a claim about who you are, and Google is authenticating you based on the credentials that you provide. Once you're logged in, you can modify your own video and comments, but not those of other people. Google is authorizing you to take certain actions based on who you authenticated as. When you leave a comment, Google keeps a record, an account of who made that comment and when they did it. Authentication, authorization, and accounting. These are the three tenets of what accounts are used for, and whether or not you know it, you use these all the time in your daily life. So, bear with me for just a moment when we make a small leap to talk about user accounts in the context of the Linux operating system. I'm authenticated as Ryan, and as always, you are authorized to be watching Intro to Hacking with Hack the Box Academy. So we're of course back at Hack the Box Academy in the Linux Fundamentals section, and if you'll remember, last time we left off on system information and I gave you guys some homework. I told you to go into that section, go down to the bottom, and do the assessment questions at the bottom. So stay tuned until the end of the video. We're going to be going over that homework, we're going to be going over those assessment questions, but for now, in case you couldn't guess it by the intro, we're going to be going over user management. Now this is a pretty short section. If we scroll down, we can see there's not a ton to it, which is why I thought it might be a good candidate for some additional context so we can delve into the weeds a little bit, explain a little bit more about how this works. So of course, the first thing we're going to want to do is spawn up that PwnBox workstation. We're going to want to get Linux in our browser ready to go. I already have mine spawned, so I'm just going to click over here, and here it is, voila, once again in the browser in PwnBox. So at the start of the video, I talked about how you're already familiar with the idea of user accounts. You probably have hundreds of these across different services, and you're definitely using an account in order to log into your PC already. You might be running Windows or Mac, but you're going to have an account there that you're going to log into, and there might even be multiple accounts. Maybe you share that computer, or you have one account for work and one account for personal use, but you're already doing this, and Linux is no different. On Linux, you have multiple user accounts that you might want to log into. You can create new accounts, you can set up accounts for different people, change and manage the permissions that each account has. It's the same standard deal as with everything else. On PwnBox, we're given a user that we're logged into by default when you open up PwnBox and start it up, and that's going to be this user right here. I'll make this a little bit bigger so we can see it easier, and we can see that our user is HTB-AC, so that's hackthebox-academy, and then our user ID on Academy. So in my case, it's HTB-AC 464110. That's the user that I'm logged into on PwnBox here. And on the left here, we also have a home folder, and this is the same home folder I talked about in the previous video, and this is where our user can keep all of their stuff, all of their documents. This is where their desktop is. This is their space to put what they need for them. In the mycredentials.txt file on PwnBox, we have our credentials for our user. We can see that the username is here, as well as the password for our user, which changes every time you're going to spawn up PwnBox, but in your case, this password would probably be static unless you changed it. Now, by no means is our user account the only account that exists on PwnBox, and by no means will the account that you log into normally be the only account on any Linux installation. There's also the root account, which is the admin account, the account that can control everything. We could log into that if we wanted to, and we'll get back to that in a little bit, but there's also going to be a bunch of accounts that aren't for people to use, but are for processes and applications and services running on Linux to use. They also have accounts, so they can run with their own special permissions, and they'll use those accounts. And we can take a look at what accounts are on the system by looking at our etsy/passwd file. So we'll just go ahead and do cat/etsy/passwd. And we get the somewhat scary looking output. There's a lot of stuff going on here, and it's not necessarily obvious what it all means right away, but if we scroll up to the top of this output, we can see the first thing outputted is this entry for the root user. Now, we talked about the root account. It is the God account, the system admin, the one that can control everything and modify anything on the system. And just taking a look at the format of this output, it's kind of obvious what the first column is. It's the username of the account. That much is somewhat clear just by looking at it. But what's not as clear is what is the rest of the stuff afterwards that are separated by these colons. What is this stuff? Well, it's not super important that you know this offhand, but we're going to go over it anyway. So I've gone ahead and labeled each of these columns, starting at 0, of course. We're good computer people. We start our lists at 0. The first thing is always 0. So in column 0, we have the username. So in column 1, we can see that each of these have an X, and that means that these users have an entry in the etsy/shadow file, which is the file that stores the hashed passwords for users. We'll talk a little bit more about that after we're done with Etsy password, but for now, just keep in mind there's a file called Etsy shadow, and that's where the hashed passwords for user accounts are stored. And the X just means, hey, there's an entry for this account in that file. Now, column number 2 is the user ID of the account. It's the number of the ID of the account on the system. Root always has a user ID of 0. Every time user ID 0, that is root. For the rest of the accounts, their user IDs depend on what they are. 0 is root, like we said. User IDs 1 through 99 are reserved for accounts that are built into the operating system themselves. So these are accounts that come predefined when you install Linux. This is your daemon account, your bin account, your sys account. We can see www data for websites, backup for backups, mail for mail, so on and so forth. These are accounts that already exist when you install Linux. 100 through 999 is used by system administration accounts. These are service accounts, accounts used by processes and services. They're not actually users, but they're applications running on the system which have their own account that are used to manage the system. If we scroll down, we can see a few examples of this. systemd timesync and network. This is time synchronization and network management. We can scroll down even more and see TCP dump or NTP, network time protocol, and so on and so forth. These are all accounts that are used to manage and administer the system, but are not actual users themselves. Accounts with user IDs of 1000 or higher are our regular users. These are the ones that you might actually issue to a person. So the account with the ID of 1000 is usually the first regular user account created on the system. The screen was getting kind of full, so I went ahead and cleared it. Column number 3 is the group ID. In Linux, you have the ability to make groups and then add users to that group, and this lets you manage the users in bulk. So let's say, for example, you had a development folder that contained some development projects on it, and you only wanted users who were developers to be able to read and write in that folder. What you could do is create a developers group, add all of your users who were developers to the developers group, and then give the developers group read and write access on that folder. Then only users who are in the developers group can access that folder. In this way, you can use groups to manage permissions in bulk and apply them to a large group of users and manage many users at once instead of applying them at an individual level. And each group has a group ID, a number that can be used to identify it on the system. In column number 3, right here, is the group ID number. We'll talk about groups more in a little bit, but just keep that in mind for now. In column number 4, this one right here, we have user information. This is a comment field. You can put whatever you want here. In the case of these pre-built-in and pre-existing accounts, this is usually just going to be a repeat of the username. For a regular normal user who's a person, maybe it's their first name. It can be whatever you want, but it's not a particularly important field. It's just there as a comment. Column number 5 is the home directory. In the case of root, this will always be /root. For normal users, this is almost always going to be in the /home folder, though it doesn't necessarily have to be. It could be in other folders, but by default, /root is going to be the root user's home folder. And other regular normal user accounts on the box are going to have a home folder in the /home directory. And lastly, in column number 6, we have the login command / the login shell. This is going to be the shell that you're going to get when you log in as the user. Now, not all users have a login shell, and in fact, most users on the machine you will not be able to log into, and we can see that with this command here, user /sbin /no login. This is what you'll put when an account cannot be logged into, so there's no login shell to run. But for user usable accounts, this will be the command, usually a shell like bash, that gets run when they log in. So in the case of root, it's bin /bash. That means when you log in as root, you're going to get a bash shell. It doesn't have to be bash, it could be another shell. There's multiple shells that you could have and use. There's Z shell or SH, but the point is whatever you put here is what will get run when the user logs in. And that is the Etsy password file. That is all of the user entries on the system. Now, I also said we would talk about the Etsy shadow file, and we'll do that now. And for this, we will need something new. For this, we'll need sudo. Now this is super user do or switch user do depending on who you ask, and this is going to let us run something as if we were root. It's going to let us run a command with the permissions of root, and the reason we need to do this is because the etc shadow file is protected. Its permissions are set such that it can only be read by root, and the reason for that is because it's very sensitive. It contains the hashes for the passwords for each user on the system, so you definitely don't want any account to be able to read that. So what we'll do is we'll do sudo cat etc shadow. And we can see a bunch of users are here. Most of these are service or system accounts that don't have passwords, but if we scroll up, we can see that there's the root account, which does have a password. And right away, we can see the HTB AC account that is our account, and this also has a password. And there's this long string here, and this is a hash. This is the hashed version of the password. So in particular, this is the hash of this password here. Now, if you're not already aware what a hash is, I could spend an entire video talking about that subject alone, but I'll try to give a general summary. A hashing algorithm is an algorithm that has a few specific properties. It takes in some data and it gives you a string of text. The string of text will always be the same if you give it the same data. So every time you give it the same data, it will give you the same exact string of text. If you change anything at all, even one bit in that data, the text you get out of the hashing algorithm will be completely different. In principle, a hash algorithm's output is supposed to be unique, that is, that no two inputs will give you the same output. However, in reality, this isn't actually true. It is possible to get two inputs to give you the same output. This is called a hash collision. Don't even worry about this. This is a very advanced topic. We're not going to delve into it. It is possible, but you can think of this as a rare occurrence. Generally speaking, no two inputs will give you the same output. And it only works in one direction. You can take the input, stick it into the hashing algorithm, and get the output, but you cannot take the output and get the input back. You can't reverse the hashing process. The reason this is useful for passwords is because it lets you not have to actually store the password. Instead, you can store the hash of the password. When the user enters their password, you just hash it and see if it matches the hash that you have saved, but if someone were to ever find the hash stored on the disk, they wouldn't be able to reverse that hash and get the password. At least in theory. While mathematically a hash cannot be reversed into its input, what you can do is just brute force a bunch of inputs until you figure out which one gives you the hash that you're trying to crack. So let's take a look at an actual example of what I'm talking about here. This hash is the hash of the password, but I can also hash anything. I could hash the word apple, for example. So if I were to do echo -n in this case gets rid of the new line, apple, and then I were to pipe that to MD5 sum, I get the MD5 hash of the word apple. MD5 is a hashing algorithm, not a particular strong one. You wouldn't really want to ever use MD5 for anything related to security, but nonetheless, we can see that I gave it apple and it gave me this string of numbers and letters. If I rerun it, it gives me the exact same string of numbers and letters. If I change anything at all, like I add a period, it's completely different. If I make one of the letters capital, it's completely different again. But if I go back and I change it back to the original apple, it's the same one that I started with. I cannot take this output that it gives me and mathematically reverse the process to get back apple. But what I could do is just try hashing a whole bunch of words and seeing what the output of that was until eventually I find one that gives me this hash. I would then know that this hash is the hash of the word apple. This is called cracking a hash. Now, cracking hashes is definitely out of scope for the context of this video, but we'll do it once just as an example. So we can use hashcat for this. We'll do hashcat -m0, that tells it to use MD5. Then we'll give it the hash, and then we need a word list, which is a list of words that it will try to hash and see if any of them match the hash that we've given it. So I'll just choose a word list that already exists on Pwnbox. Opt, useful, seclist, passwords, zato net 10 million passwords.txt. So this is 10 million passwords that exist on a file on Pwnbox. We'll do -o for optimized kernels, and we'll try to run it and see if we get a crack. And it cracked it basically instantly. We can see right here that it cracked the hash and it found out that apple, when hashed with MD5, gives you this hash, and now we know that this hash is apple. And this is exactly why you don't want users to be able to view your etc shadow file, because if they get the hash, they can try to crack it and they'll figure out what the password is for a given user. So we've talked about where user entries are stored, where their passwords are stored. Let's talk a little bit about managing users themselves. If we wanted to add a new user to the system, we would simply do sudo user add and then the name. I'll add a user called Ryan. I've just added a user called Ryan, but you notice that I didn't actually enter a password. So right now, Ryan doesn't have a password. So then we have to do sudo passwd Ryan, and this lets us set a password. I'll make this password for this example, and now password updated successfully. There's now a user called Ryan, and he has a password of password. And if we were to cat the etc passwd file, we can see that there's a new user entry, user 1001, and it has the username of Ryan, and its login shell is bin/sh. And if I were to do sudo cat etc shadow, we can see that it shows up in the shadow file, and the hash of the password, which is just the word password, also shows up here as well. And we could also add Ryan to a group so we could gain the permissions from a given group. There's a group on Linux called ADM. This is a group that gives you permissions to read log files. So let's go ahead and add Ryan to the ADM group. Sudo add user Ryan ADM. This will add the user Ryan to the group ADM. And now he's in the group ADM. Now, if I decide I don't like Ryan anymore, he called me ugly, I'm not a big fan of him, we're going to delete his account. I can simply do sudo user del Ryan, and he's gone. He no longer exists, he's out of the picture, he doesn't have an account anymore. Instead, let's try adding ourselves to the ADM group. But first, let's just see what groups that our user HTB AC is a part of. So we can do groups, and this tells us that we're part of the HTB AC 464110 group, and as well as the sudo group. Every user also has a default group that's typically just their username as well, so we're in that group, and then we're also in the group sudo, which means we have the ability to run the command sudo. Let's try adding ourselves to the ADM group. We'll do sudo add user HTB AC 464110 ADM. And it added us to the ADM group. Now, if we run groups, we would expect to see ADM listed, right? So we'll run groups and see what groups we're part of. But there's no ADM there. That's interesting. We just added it. It says that it did it, but if we ask what groups we're a part of, it's not there. And the reason it's not there is because of how groups affect permissions for processes. Right now, we're logged in as the HTB AC 464110 user, or at least I am, and I'm running a parent terminal instance that has a bash shell, and both of those are running in the user context of HTB AC 464110. And while I did just add myself to the ADM group, the problem is that when these processes were started, I wasn't in the ADM group. Processes gain their permissions as attributes when they're run. So because these processes were run before I added myself to the ADM group, they don't have the ability to access the ADM group. So when I run groups to see what groups am I currently a part of in the user context that I'm currently running as, it doesn't have ADM because when it was run, it wasn't a part of the ADM group. I could also try spawning maybe a new shell as me. I'll spawn a new bash shell and we'll try it again. But it still doesn't work, and the reason why is because when I spawned a new shell, it just spawned it as a child process of the process that was already running, and it just inherits those permissions. We can see this if we actually take a look at the way the processes are running. We can do that with ps -auf. And we can see that there is a bash process that was running as the HTBAC user, and then it spawned a bash process, which also gets run as the HTBAC user. Because my original bash process spawned the new one just inherits the attributes of the parent, and it doesn't have the ADM group because the parent doesn't have the ADM group. Every time a process spawns a new process, the new process just inherits the parent. So the question becomes, how do I get the change I made to my groups to take effect? Well, when you first log in as a user, you run your login shell. And that is the very first process that gets run, and everything else becomes a child of that. So I need to rerun my login shell to get a new version of it that has the updated group, and then it will take effect. I can do this by running the login command. So I'll do sudo login HTBAC 464110, and we'll have to enter the password from this my credentials file, and we'll paste that in. Now I'm freshly logged in once again, and now if I do groups, we can see that I'm in the ADM group. Now I can also log in as other users in real time. I can use what's called switch user to log into a different user. So we'll create a new user once again, and we could use the user add command, or we could also use the add user command. If we use add user, it's going to prompt us for the password right away, so we'll do that this time. Sudo add user Ryan, and it's asking us for password. We'll do password once more, and it's going to ask us for some information. We won't fill it out. Now we can do switch user Ryan, and it's going to prompt me for a password. I'll type password, and if I do who am I? I'm now Ryan. Now anything that I spawn will be in the Ryan user context. So if I do a new bash shell and then I do ps minus AUF, we can see that there is this tree here and it's a little bit cut off. We'll do it again. There is this process tree here where the very parent is HTB AC4. There's this process tree where the top parent is a bash process that's running as the HTB user. Then that process spawned another bash process also running as the HTB user. Then we did sudo login as the HTB user, which was running as root because we did sudo, and we logged in, which was also running as roots, brought us back to the HTB user. We did su Ryan, which ended up being run as root because switch user runs as roots. And then from that point on, we were in the Ryan user context for this process tree. So you can see how as you switch users and as you use sudo, for example, to run something as roots, the processes change what they're running as. Every time you run a process as a user, the process inherits the permissions of the user that you ran it as. Now, you may have noticed that I've been running sudo a lot, but I haven't had to type any password. Why, if sudo runs as root, do I not have to type a password? Now, normally you would. Normally when you run sudo, you'd have to type your password in order to do it. However, on Pwnbox, we've removed this by using the Sudoers file, which controls sudo permissions. So we can take a look at that right now. If we type sudo cat etc Sudoers, we can see that we have allowed anybody who's in the sudo group to run everything with no password. They can run any command without entering their password if they're in the sudo group. Now, this is a terrible security practice. You would never want to do this unless you had a very good reason and you knew exactly what you were doing. Like, for example, if you were running a sandboxed VM that only has a couple hours as a lifetime and the users can have full carte blanche to do whatever they want, like with Pwnbox, that's a good example of when you might want to do this. But generally speaking, you don't want to let your users run anything as sudo without typing in their password, because if a malicious user gets a shell on the box but doesn't know the password, they'll be able to run whatever processes you've specified as root even though they don't know the password. And that's dangerous because sometimes, even when you allow what you think is a benign process to be run as root, it can be used for malicious purposes. Take, for example, the find command. If I do find /-name something, we'll do conf, right? This is going to search the entire file system for conf files, but you can see up here I'm getting a lot of permission denied. So maybe you want to let your users search for files on the system and you don't want them to get a bunch of permission denied errors. You want to let them search everything, so you'll say, okay, I'll give them the ability to run find with sudo permissions without having to enter their password. Seems reasonable. Find seems pretty benign. However, if we type man find, we view the manual page of the find command, and then we can search for the phrase exec. There is a flag you can give find that's very much an intended part of its functionality that just executes a command. So right now I am HTB AC464110, but let's say that you gave me the ability to run find with sudo without entering a password. I could do sudo find, we'll search the current directory, and then we'll do -exec bin bash, some additional stuff so that the command works without being weird, and then I'll run this, and now I'm root. Find gave me root, and find is not special. There are hundreds of commands that will do this. There's an entire website dedicated to it called GTFO bins. You don't want to give people the ability to run commands as sudo without a password unless you know what you're doing, have a very good reason, but even then, probably not. In the case of Pwnbox, it makes sense because Pwnbox is just a sandbox, but this is not a good practice in production. Now, that's all I had prepared for this section, but I also said I would be going back and doing last time's homework. So we're going to go into the system information section, and we're going to do the questions from the last video that you guys are supposed to have done on your own. So let's get into that right now. So I'm back at system information. We're going to scroll down to the bottom of the module, and the first question is find out the machine hardware name and submit it as an answer. Now, this question is a little bit ambiguously worded. You might think that machine hardware name refers to the host name, but it doesn't. It's phrased machine hardware name because that's explicitly how it's worded in the documentation for uname. If we go over to an article that I found just by Googling, we can see that there's a bunch of ways to get different names of different things. But if we scroll down here, we can see printing machine hardware name through uname -m gives you the hardware name. And in fact, if we were to go back over here and go into man uname, we can see that -m prints the machine hardware name. So that's why this question is worded in that way. So let's go ahead and actually run this. Uname -m. It's x86-64. So you might also think about this as being the hardware architecture. So we'll enter that in as the answer, x86-64, and success. We earned 0 cubes. what is the path to the HTB student's home directory? Okay, in this, we're going to need to actually spawn this target system here. And I should mention that I really should have ran that uname command on the target system, but the answer is the same anyway, so it worked in this case. So our target system is spawned, and it's 10.129.61.62, so we'll SSH into that, SSH HTB students at 10.129.61.62, and I believe the password is HTB Academy student. It is, so we'll hit enter, yes, and HTB Academy students, and we're logged in. Resize the shell there so it's a little bit easier to see, and we'll move on to the next question, which is what is the path to the HTB student's home directory? Well, if we just ls/home, we can see that the HTB student has a directory in home, so it's going to be /home/HTB students. Submit that as the answer, and that is correct. So the next question is, what is the path to the HTB student's mail? Now this is a little bit difficult. There's a few ways we could try to find this. We could try to Google where mail normally is and take a guess, or we could try to search for the word mail into different folders and see if we could find it that way. But the easiest way here is to use what is called env. We're going to look at the environment variables, because on Linux there'll be an environment variable called mail, and that will tell you the path that mail is stored for your current user. So if we type in env, we can see the current environment variables, and there's a lot of them. So maybe if we do env and then we grep for mail, and I did a mistake there, I added a new line. Do it again. Here it is. Mail equals var/mail/HTB student. So we'll try that. Var mail HTB students. Submit, and congratulations, you earned 0 cubes. Which shell is specified for the HTB student user? Well, we talked about this earlier actually. We can take a look at the etc password file for that. If we cat etc password, we can see that bin/bash is the shell provided for HTB student. We could have also just checked which shell that we're currently running as. We could do that with echo shell, which echoes the shell environment variable, and we can see bin/bash there as well. Next question, what is the kernel version installed on the system? Well, normally we would use uname -v for this. But on Ubuntu, which is what this is running, uname -v actually gives you the Ubuntu release version instead of the kernel version. So instead what we can do is uname -a, and we do get a kernel version here. We get 4.15.0. So we'll try that, 4.15.0, and that is correct. And lastly, what is the name of the network interface that MTU is set to 1500? Well, in order to do that, we have to take a look at the network interfaces. So we can do that with IPA, and there are two network interfaces here. There is LO, which is loopback, it's the localhost interface. That's not going to be useful for us. So we'll take a look at the next one, and this is ENS 192. We can see that MTU is set to 1500, so the answer is ENS 192. Go ahead and submit, and we're done. We'll mark that section as complete and next. So now your homework for this time is to go down and answer these questions right here. I want these ones answered before the next video. Go ahead and read through this short little section here, look at these commands, answer those questions, and we will go over those in the next video. So that's it for this video, guys. I hope you enjoyed it. I added about as much context as I thought was appropriate for this section of the module. And in the next section, we're going to be talking about package management, and then we're going to go into services and processes, and then we're going to finish off the system management portion of the Linux Fundamentals module. So I'll see you then, but until then, goodbye, world.